So this question says two guy wires are anchored at the same point. Okay, that would be down here. The 15-meter guy wire is attached to the top of the tower, and the 12-meter guy wire is attached to a point 6 meters below. How far apart are the wires anchored from the base? So actually what we want to know is this little distance down there. Okay, well, what I've got here, if I ignore this triangle kind of down below, what I've got is a triangle that is clearly not a right angle triangle. And I'm going to use one of my rules to figure out a bit of information from it. In fact, the information I'm going to figure out is this one right here. That angle. And the reason why I want that angle is because that angle is part of the largest triangle here, and that's going to allow me to figure out what x is. So what I'm going to use here is I've got a triangle now, that triangle that's not a right angle triangle. I have got the three sides, and what I want here is I want to figure out what that angle is, and the side opposite that is the 12. So let's just call that theta. Theta is going to be the inverse cosine, because this is definitely the cosine law, and I'm going to have minus 12 squared. So I've talked about this in a previous question here. When I'm looking for angle theta using the cosine law, I'm going to subtract the opposite side squared in the numerator. Then it doesn't really matter what order these other two sides come in. So it'll be 15 squared plus 6 squared. And in the denominator, it'll be 2 times 15 times 6. Or 6 times 15. It doesn't really matter. Now, when I do this on my calculator, I simply have to remember to make sure that I put brackets around the numerator and around the denominator here. So 15 squared plus 6 squared minus 12 squared divided by 2 times 15 times 6. Do this on my calculator. And I get that theta is about, well, it's about 49 degrees. Okay, I've got a little bit of a decimal there, and I'm going to leave that on my calculator, and I'll use it when I go to do the next step here. Now I'm going to look at this larger triangle where this is 15, this is 49 degrees, and I want to figure out what x is. Well, that is going to be an application of just plain old sine. The sine of 49 degrees will equal x over 15. And then I can multiply up by that denominator to get x is equal to 15 multiplied by the sine of 49. So now I'm going to go to my calculator, 15 multiplied by the sine of, but I'm not going to use exactly 49. I'm going to use the decimal that the calculator gave me. Okay, and press enter, and I'm going to get, when I round that to the nearest tenth, that is 11.4 meters.